All right, so we can also find new Taylor series from a product of two series. Now this gets a little hairy, and you might be asking yourself, "Well, I've got two Taylor polynomials that go on forever, ever, right? Or Taylor series, right? That go on forever. So they're essentially polynomials that go on forever. How in the world am I supposed to multiply those together? So just bear with me. It gets a little hairy, but it's not bad. So let's take a look at this. We're trying to find the Taylor series for sine x times cosine of x. Okay, we know the Taylor series for both of those. So sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial and so on, right? And I want to multiply that times the series for cosine, which is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial and so on. Okay? Now, if this was just a regular polynomial, you just FOIL it. I guess that's how we do, binomials. But essentially, you're just applying the distributive property. So I'm just taking every term times every other term. And we only need the first four non-zero terms. All right, so sometimes you just have to dive in and just start working with it. So let's see. I'm first of all just going to take this first x term, times every term, at least that I've got listed here, in the Taylor series for cosine. Okay, so I'm just basically taking, I'm just taking every term in the first polynomial, or not polynomial, the first series times every term in the other polynomial. But I'm just going to start with x. Okay, so I'm taking x times everything. So I'm going to get x minus x cubed over 2 factorial plus x to the 5th over 4 factorial, right? I'm just taking x times everything in the cosine series. So then the next thing I'll get is x to the 7th over 6 factorial, and so on. All right, I only need the first 4 terms, so I'm just going to work with the first 4 terms. So we're only going to go up to the powers of 7, right? And so now I'm going to move on to the next term. So I'm going to erase that. Now we're going to move on. Maybe she used red. Yeah, mark it with red. So now we're taking this term in the sine polynomial, and we're going to multiply it times everything in the cosine polynomial. So the first one, I'm just going to take the x cubed over 3 factorial times 1. So I'm going to get minus x cubed over 3 factorial. And I'm just going to kind of line it up with the like terms from the last multiplication I did. And then I'm going to move on because I'm taking this x cubed. I'm going to circle it. That would keep track of where I'm at. I'm going to take the x cubed over 3 factorial. Going to take it times the next term, right? So that's the x squared. So I'm going to end up with, let's see, they're both negative. So I'm going to end up with a plus x to the 5th over 3 factorial times 2 factorial. Okay, now I'm going to take that same x cubed over 3 factorial and multiply by the next term. Now, the x cubed that I'm using in the sine polynomial is negative, and the other one's positive, so I'm going to end up with a minus x to the 7th over 3 factorial times 4 factorial. Oops, that should have been x to the 7th. How did I write x to the 4? All right, let's make that x to the 7th. All right, you can see I'm lining it up. I'm lining up all of my x to the 7th terms because I want to eventually add them because they're like terms. And any other terms are just going to be higher than the power of 7, and I'm not going to bother with those. Okay. All right, so now I want to move on. I'm going to see if I can erase this without erasing anything else. And I want to move on to the x to the 5th term here, right? And I'm going to multiply that times everything in that cosine polynomial. So I'm starting by multiplying the x to the fifth over 5 factorial times 1. So that's just x to the fifth over 5 factorial. Okay, and then I'm just going to keep going, but I only want to go up to x to the seventh. So the next one's just going to be x to the seventh over 5 factorial times 2 factorial. Okay, and then I'm done because I don't need anything beyond the x to the seventh term. So then finally I'm going to move on to the x to the seventh term, and I really only need to multiply that times times the first the 1 in the sine, or sorry, the cosine Taylor series, right? So I'm just going to have minus x to the seventh over 7 factorial. And then we don't really care about the other terms. All right. So now you can see I've lined up the like terms because those are the ones I want to combine, right? I want to combine like terms. Let me scroll down just a hair to give myself a little more room. So, you know, sometimes the hardest part in these problems is the arithmetic, right? Because now, okay, well, I know the first term is going to be x, right? And then I have to take, okay, x, so minus x cubed over 2 factorial plus minus x cubed over 3 factorial. So basically, we have to add up 1/2 and 1/6. So 1/2 plus 1/6 is essentially 4/6, right? Because this is 3/6 plus 1/6 is 4/6, which is 2/3. Okay, but it's negative, so it's a minus 2/3 x cubed. All right, so we just have to keep doing that. And again, the fractions are a pain. So I've already calculated these, so I'm just going to write them down. I don't think you want to watch me go through the arithmetic on this, but I tell you that can be oftentimes the hardest part of these problems. In the Wiley homework, I believe they want all of these things to be simplified with no factorials. So I don't know if Wiley just can't handle factorials, but so you have to simplify them, and I don't think it'll allow decimal approximations for the coefficients, and so you have to actually work out the fractions, which is a pain. So so I worked these out. You can actually use your calculator too to do fractions. You can convert a decimal to fractions. So if you have a question about how to do that with your calculator, at least I know you can do it on a TI-84. So, and that's honestly how I got some of these, because you end up with these big ugly fractions. Like this last one for the x to the seventh term, you end up with you know, minus 1 over 720, minus 1 over 144, minus 1 over 240, and then minus 1 over 5040. And that's just nasty. All right, so I just did it in my calculator. But, okay, let me show you another trick with this one. It happens to work with this one because there's a trig identity that we can use. So we can use a trig identity. Maybe you saw this right off the bat. I don't know. Because you remember back when we did trig substitution, or we did some trig integrals, we used the identity that the sine of x cosine of x is equal to 1/2 the sine of 2x. You know, so have those trig identities handy. And we know the Taylor series for the sine of x, so we can do a substitution, and what we end up with is 1/2. Let's see, we end up at 2x minus 8x cubed over 3 factorial plus 32x to the fifth over 5 factorial minus 128 over 7 factorial x to the seventh, and so on. Okay, so I'm just sorry, plugging in 2x and then taking it to the power. So, you know, 2 to the seventh is 128. And then if I want to simplify it, I can multiply through by 1/2, and I'll end up with x minus 2/3 x cubed plus 2 over 15 x to the fifth Mine is 4 over 315 x to the 7th, and so on, which matches, so that's good. It's always good to do a problem 2 different ways and get the same answer, and you can feel fairly confident about your result. All right, so one more example I want to go through, and then you'll be ready for the discussion questions.